So we take one more step to look into where the motion is. So it's more like tracking the movement rather than just identify the movement. Okay, so we tidy up the screen and then create a new file. Like tracking 001, and in this exercise we just make use of the webcam to track everything without using other external resources. So we need to have your video device in. Yes, and then again flip the video horizontally. Here, flip X. So similar to the last exercise, we work with identifying the motion with those vertical stripes. So we again need to keep track of two images by using the catch. So the first one, and if you do not want to use 32, and then you can reduce it, for example like half of them, 16 will be enough. And next step we'll do the catch select similar to the last one by dragging the catch into the catch top of catch select. We keep a storage of the 16 images, and this number 0 to a minus number will retrieve the previous image. So like if we take -5, so it will go back in timeline to find the last 6 images, and then we can make a comparison between the two images by using difference, and that will give you the change of the image. And if you have fast movement, so you can change the size to be a smaller number, to be a number closer to 0, like -3. You can detect a bit more faster image or faster movement. And if you have very slow motion in front of the camera, so you can make it a smaller number like -5, -6 or so. So the different image will be a color image, and actually we don't need to have a color image for detecting the motion. We can convert it into monochrome. That is pure black and white and grayscale, like this. So this is the motion. Or even you can go one step further by doing a threshold. Threshold will give you pure black and white and without the gray tone. So we can have a look. So the area with movement you have noticed is white in color, the rest is transparent. And you can also customize this threshold slider. So the bigger the number, the more difficult you generate this movement or the white area. The smaller the number actually will give you more response from the screen. So we put it to around 0.4. So this is what we're going to start with. So now actually you have some mechanism to identify movement. So in order to locate the movement, actually those areas with the larger regions of white will indicate that the major motion or major movement appear in front of the camera. So the next step is we try to find out those area. In TouchDesigner, actually there's a very handy objects in TOP with the name called Blob Track. So if you send your threshold black and white image over there, you can like turn on the display. It is something like this. So the area you have motion, actually you will notice there's a square. So that square is indicate the area with the major movement. So as we are using the free version of TouchDesigner, if you click on the middle mouse button, that's the wheel. So it indicates the block detection limited to 2 area of blocks with non-commercial license. So this is the only restriction. So now we have an indicator to locate where your movement is, that is the square. How can we obtain the location of the square? So this is the next step. So the next step is a very generic step we're going to do. In CHOP, C-H-O-P, there's one we have the name called info, which is a very useful object. And for every operator or objects, you can just drag into the operator entry, and then you release. And once you drag it over here, the info chop actually will create a number of this information that give you details about your particular objects. So in the Blob Track object, we basically have information about the size of the screen and the number of blocks is detected. And in our case, when we make some motion in front of the camera, actually you will see that there are 2 extra indicators with the name called BLOB0 and BLOB1 that indicate the area with the motion detected. So to get those information out, we use a select chop. So we connect this one over here, and in the parameter for this select chop, we only select those with the name BLOB0. BLOB indicates that a small region of area that we are interested in, and then we put a star asterisk here, which usually refer to something like a wildcard. And when we press enter, so you see that whenever there's a block detect, it will show you the block ID, UV, width and height, where U and V correspond to the horizontal and vertical location of the detected area. So those are actually the 2 values that we would like to use to track the movement. So rather than obtaining all the blocks 0 colon something, we would like to modify it just to obtain the BLOB0 colon U and the BLOB0 colon V over here. So in this case, you only retrieve 2 values. The U and V correspond to the X and Y. And sometimes you may find that the name of the variable is a little bit clumsy, BLOB0 colon U and colon V. So we can actually rename it in the select chop by putting just X space and Y. We'll modify the name to X and Y. So now we have the 2 values, that is X and Y indicate the location where you detect your motion. So one difficulty is if I am sitting still in front of the camera actually there's no movement, and whenever I move there will be the value x and y. So that will give you some difficult situation that when you would like to draw, for example, some graphics in the area you detect the movement. So how can we deal with this one? We're going to use a command called feedback in chop. So start with F. Yes. In the feedback chop, when you connect the value over here, and when you have movement, the x and y, so it will store into the storage. And even though when in the next frame there are no motion at all, the previous value of the x and y remain there. So this is the beauty of using the feedback. And we also need to put one more in the second input, which is the initial situation. That means when you start up your computer and when there's no motion in front of the camera, this value of x and y will be undefined unless you initialize it to some initial value. So if we move in front of the camera, we might notice that the two ranges is just between 0 and 1. For x, 0 means the left margin, and 1 that is will be the right margin. And for y, similarly, the top one will be 1 and the bottom margin will be 0. So if we want to locate the initial position in the middle of the screen, we can just put one value for x and y that's in the middle of the screen, that is 0.5 and 0.5. To do this, we can add a constant and then connect the constant to the second one. But also remember the changes to the same name. So the first constant is x, and then we can add one more constant y, and with the initial value of 0.5 and 0.5. So that means when you switch on your computer before any motion is detected, so that location will always be in the center of the screen until you start to move, and then you change the position. Okay, so now we have the x, y. So what we are going to show on the screen is we would like to create a graphics and then let the graphics move according to this x and y value. So what we are going to create is like, we start by creating one graphics that follow the x movement first, and then we can add another one to follow the y movement for explanation or illustration. Okay, so we start with creating a rectangle. And we change the resolution of the rectangle to the custom, that is size of the screen. Yes. And for example, if I would like to create a line, so a vertical thin line to walk or to move according to the x value, I can do a very thin line like this and then make it longer. So the line will be something like this. And if you would like to make it a little bit more thinner, you can also make it like this. And if you would like to change color, you can also change color. Okay, so this is the line, and we hope that will move according to x. To move the line, we need to have a transform that put it around here. And if we turn on the display, like if you move it to 0.5, that will move towards the right margin, and minus 0.5 will be towards the left margin. So this is the range of the movement. And if we take a look of the feedback value, so the range that we discover will be between 0 and 1. And the next step is we need to convert the, so we're not going to do a merge, but instead going to have a mask to convert the range from 0 to 1 back to minus 0.5 to positive 0.5. So this can be done with the mask in the range, like 0 to 1 is the from range, and minus 0.5 to positive 0.5 will be the to range. So this will be the conversion of the range in the two direction. So now we are ready to put it into the translate. Before that, it will be a good habit to put a null in the chop, such that this dummy null chop will be used to put it into the transform, just in case we would like to add something in between. Okay, so we select the transform that look into the translate area, and then in the null chop we turn on the viewer active and drag the X value over to the translate X, and then export this chop. And if we turn on the display, there will be something like this. So when you try to move in front of the camera, so I try to give you my image as well. So this is the flip image. So that means when I move in different direction horizontally, so that line is kind of following my movement. So now we are more or less finished, and except that you would like to show something in the output window, so that can be done by combining the two images by using a composite. The first one is your flipped image, and the second one is your vertical line, and then send out to the output window. And of course you need to change the operation in your composite. I think in this case we may use under. So this is your video image under the vertical line. So we can perform our usual step in the perform window to change the output opening size to fill screen, and also disable the border. So the result will be something like this. So when you move, so actually moving your vertical line with your motion. And the result is correct, but not in particular satisfactory. So the mixing step, or something that we can improve, is somewhere in between here that I mentioned. So after the calculation, you find that the line follow exactly the movement. The movement actually are a little bit quite irregular, in a sense that it's kind of jumping from one location to the others, which is the effect of the motion detection. So to help to make it a little bit more nice, in a sense that we can do something to smooth them the operation by inserting an operator, that is a chop, over here with the name called filter. So the default filter is the Gaussian. This is something like the Gaussian blur that you use in Photoshop filter. So the result will be kind of like the smoothing the operation of the motion of your vertical line. So the result will be something like this. So the movement will not jump directly, but it's kind of like taking a few steps in order to go to the area with motion. So this is something that you can play around with. For example, if you have some objects around here moving and you have another one kind of catching. Of course, the movement in the center also affect the tracking. So this is the fun of playing with this. Okay, so this one actually is the first demonstration, and of course we have make room for the Y direction as well, so you can have one more line, or you can just change the object to a smaller icon that can follow both an X and Y direction, and you can have more fun with your motion detection.